Good morning, everybody. BSc Part 2, paper number 5, Physical Chemistry. The topic is electrical conductivity. So, just here, first we will see the review of the topic. म्हणजे आत्तापर्यंत आपण टॉपिकमध्ये काय काय शिकलेलो आहोत याचा थोडक्यात आपण आता आढावा घेणार आहोत. फर्स्ट पार्ट दॅट इज मेटॅलिक कंडक्टर and electrolytic conductor. The material which carries electric current after applying an electric field, that is called as conductor. There are two types. One is metallic and second is electrolytic conductor. So in metallic conductor, the current carriers are free electrons, while in electrolytic conductor, the current carriers are number of ions. So that is the main difference between them. Now the term we have seen, that is conductance, which is denoted by the letter G, which is the reciprocal of resistance. So G is equal to 1 divided by R, and its unit is ohm raised to -1, or it is called as per ohm. Now the second term we have seen specific resistance, that is denoted by letter rho. Rho is equal to RA divided by L, and its unit is ohm centimeter. Third term we have seen, that is specific conductance, which is denoted by the letter small k, or it is called as, in Latin words it is called as kappa k. So it is a reciprocal of specific resistance. So its unit is S per centimeter. So specific conductance k is equal to 1 divided by rho. Then the term equivalent conductance. Equivalent conductance denoted by the letter lambda v, that is equal to K multiplied by V. K is specific conductance and V volume, which contains 1 gram equivalent of an electrolyte. So that is the equivalent conductance, and final relation we have already seen, that is equal to 1000 K divided by N, where K is the specific conductance and N is the normality of solution, and its unit is S centimeter square. In similar manner, we have seen the molar conductance, which is denoted by the letter lambda M. Equivalent conductance lambda V, molar conductance lambda m, and that is, it is also mu v, it is called as. So lambda m is equal to also kV, K that is specific conductance, and V volume here containing 1 mole of an electrolyte, and finally its equation is 1000 K divided by m, where m is the molarity of the solution. So the difference between equivalent and molar conductance is, here is the normality N in equivalent conductance, and here is the molarity M in terms of molar conductance, and unit of both are S centimeter square, H centimeter square. So S centimeter square per equivalent, and here S centimeter square per mole. So that is the difference between them. Now we have seen the equivalent conductance at infinite dilution. The dilution at which the value of equivalent conductance is maximum, that is called as equivalent conductance at infinite dilution. Similarly, molar conductance at infinite dilution, the dilution at which the value of molar conductance is maximum, that is called as molar conductance at infinite dilution, and it is denoted by the letter mu 0. So this is the equivalent conductance at infinite dilution. Now we have already seen what is strong electrolyte, what is weak electrolyte. So the electrolytes like HCl and NaOH are called as strong electrolytes. So in terms of conductance values, initially its conductance values are very low, and it increases with the dilution. So strong electrolytes. And the weak electrolytes, acetic acid, NH4OH, these are called as weak electrolytes because initially its values are high, and as dilution increases, its value decreases. As dilution increases, its value decreases slowly. So that is the main difference between the strong electrolyte and weak electrolyte. So what is the effect of dilution? One part is there. What is the effect of dilution on equivalent conductance, specific conductance, and molar conductance? So as dilution increases, the number of ions per solution decreases, and specific conductance also decreases in case of specific conductance. As dilution increases, the equivalent conductance and molar conductance also increases. So that is the effect of dilution and on different types of conductances. Now how to measure the conductance we have already seen in terms of Wheaton's bridge. So the equation is Rx is equal to R2 R3 divided by R1. If you know the values of unknown resistances R2, R3 and R1, then you can easily determine the value of Rx, that is unknown resistance, and by taking the reciprocal of 1 divided by Rx, you can get the conductance. So that in that way you measure the conductance. This term is we also see. Now the next part, that is we have already seen, that is called Large's law. So the mathematical statement, lambda 0 is equal to lambda 0 plus lambda 0 minus. So equivalent conductance at infinite dilution is the sum of the ionic conductance of positive ion and that of negative ion at infinite dilution. In case of HCl, by applying Collar's law, lambda 0 of HCl, it gives lambda 0 of H plus lambda 0 of Cl minus. If you consider lambda 0 of CH3COOH, so it becomes lambda 0 of H plus lambda 0 of CH3COO minus. In that way, you can split any electrolyte at infinite dilution. Similarly, in case of molar dilution. So Collar's law is here. And what are the applications of Collar's law? We have already seen. So application number 1, relation between ionic conductance, equivalent conductance, and that of transport number. So lambda 0 plus is equal to lambda 0 into T0 plus. So lambda 0 plus ionic conductance of positive ion at infinite dilution is the product of equivalent conductance at infinite dilution multiplied by transport number of that ion. Similarly, lambda 0 minus is equal to lambda 0 into T0 minus. So it is a product of equivalent conductance at infinite dilution and transport number of that ion at infinite dilution. So this is the relation between equivalent conductance, ionic conductance of that ion, equivalent conductance, and that of transport number. So this is the application number 1 we have already seen. Now application number 2, that is determination of degree of dissociation of a weak electrolyte. So degree of dissociation is related by the term alpha. So its formula becomes alpha is equal to lambda V divided by lambda 0. Alpha is equal to lambda V divided by lambda 0. This is the equivalent conductance at a particular dilution to that of infinite dilution. Similarly, in case of molar conductance, it is lambda m divided by lambda 0. It is molar conductance at a particular dilution to that of infinite dilution. If you know both the values, you can determine degree of dissociation alpha. So third, that is determination of solubility and solubility of sparingly soluble salt and solubility product. So solubility product Ksp is equal to x square, and here the value of x becomes square root of Ksp by this equation, and you can determine the solubility x is equal to the specific conductance of that salt divided by the ionic conductance of both the ions in that salt. So this is the solubility and this is the solubility product, and its unit is mole per meter cube. The fourth application, to determine the ionic conductance of water. So, or ionic product of water rather. So Kw is equal to 1 into 10 raised to minus 14. हे तुम्हाला माहितीच आहे. So by applying Collar's law and by using the ionic conductance of H plus ions and OH minus ions, how to determine the ionic product of water? So Kw is equal to 1.02. So 0 to it is very negligible. So it is Kw is equal to 1 into 10 raised to minus 14. That is the ionic product of water. Fifth application, we have already seen how to calculate the hydrolysis constant. So its value Kh is equal to H square into C divided by 1 minus H. So hydrolysis constant, that is equal to Kh, and H here, that is called as degree of hydrolysis. C is the concentration. So you know the concentration, degree of hydrolysis. By substituting all the values in this equation, you can easily determine or calculate the hydrolysis constant Kh. Next value, that is determination or application, is determination of lambda 0, ionic conductance at infinite dilution or equivalent conductance of infinite dilution of an weak electrolyte. So by giving some examples, we have already seen how to calculate or determine the equivalent conductance at infinite dilution of an weak electrolyte. So these are the applications of Collar's law. Next part, we have seen the conductometric titrations. The titrations which are carried out by measuring the conductance value called as conductometric titration. So by plotting a graph of conductance value against ml of alkali solution added, we have seen all the 4 titrations carried out by measuring the conductance. So first, that is titration between strong base, strong acid, NaOH, HCl. Second, titration between strong acid, weak base, HCl, NH4OH. Third is titration between weak acid and strong base, acetic acid, NaOH. And fourth is titration between both weak, that is acetic acid and NH4OH. So these are the 4 titrations, and by plotting a graph of all these titrations, we can easily determine the endpoint, or in terms of endpoint, in the conductometric titration, it is called as equivalence point. So by determining the equivalence point, how to calculate the solution, unknown normality of that solution, we have already seen. Now, what are the advantages of these conductometric titration? So there are different types of titrations: volumetric titrations, potentiometric titration, complexometric titrations, idiometric titrations, and these are the conductometric titration. So what are the advantages of this conductometric titration over volumetric titrations? So first advantage, titration of colored solutions. जेव्हा colored solutions titrations मध्ये असतात, KMnO4 असेल, पोटॅशियम डायक्रोमेट असेल, कॉपर सल्फेट असेल, अशा टायट्रेशन्स आपल्याला ह्या कंडक्टोमेट्रिक टायट्रेशनद्वारा इझिली आपल्याला करता येतात. सो टायट्रेशन बिटवीन दी कलर्ड सोल्युशन. नंबर 2, फॉर व्हेरी डायल्यूट सोल्युशन 0.1, 0.001, कितीही डायल्यूट सोल्युशन असू दे, ह्याची टायट्रेशन्स आपल्याला चांगल्या पद्धतीनं करता येतात. नंबर 3, टायट्रेशन बिटवीन वीक ॲसिड अँड वीक बेस. हे जे टायट्रेशन आहे, दोन्ही जेव्हा वीक असतील तेव्हा आपल्याला ही टायट्रेशनसुद्धा करता येतात. इथं आपण बघितलेलं आहे टायट्रेशन बिटवीन ॲसिडिक ॲसिड अँड दॅट ऑफ NH4OH. मोर ॲक्युरेट रिझल्ट्स आर ऑप्टेन. तर व्हॉल्युमेट्रिकच्या तुलनेत हे कंडक्टोमेट्रिक टायट्रेशनचे रिझल्ट्स जे आहेत, ते रिझल्ट्स काय असतात, मोर ॲक्युरेट असतात. इथं आपण काय करतो की कंडक्टन्स मेजर करतो, अल्कली ब्युरेटमधून त्यामध्ये ॲड करत जातो, आणि कंडक्टन्स अगेन्स्ट ml ऑफ अल्कली सोल्युशन याचा ग्राफ काढतो. दोन्हीचा पॉईंट ऑफ इंटरसेक्शन जो असतो, तो इंटरसेक्शन आपण काय करतो, इक्विव्हॅलन्स पॉईंट म्हणून घेतो, आणि याच्यावर आपण काय करतो, अननोन नॉर्मॅलिटी सोल्युशनची नॉर्मॅलिटी कॅल्क्युलेट करतो, आणि रिझल्ट्स आपल्याला ग्राफिकल असल्यामुळं हा रिझल्ट ॲक्युरेट मिळतो. फॉर प्रेसिपिटेशन टायट्रेशन, अशी काही टायट्रेशन्स असतात की प्रेसिपिटेशन टायट्रेशन, त्यामध्ये आपल्याला व्हॉल्युमेट्रिकच्या सहाय्याने कलर चेंज लक्षात येऊ शकत नाही. अशी टायट्रेशन्स आपण कॅरी आउट करू शकतो. फॉर एक्झाम्पल इथे दिलेलं आहे KCl, पोटॅशियम क्लोराईड प्लस AgNO3, सिल्वर नायट्रेट, व्हाईट प्रेसिपिटेट ऑफ सिल्वर क्लोराईड इथं काय होतो, तयार होतो. आणि अशा पद्धतीचे टायट्रेशन्स आपण कंडक्टोमेट्रिकली इझिली कॅरी आउट करू शकतो. नो इंडिकेटर इज रिक्वायर्ड. प्रत्येक व्हॉल्युमेट्रिक टायट्रेशनला आपण बघतो, फिनॉल्थिलीन वापरतो, मिथिल ऑरेंज वापरतो, त्यानंतर इरिओक्रोम ब्लॅक टी इंडिकेटर वापरतो, डायफिनिल अमाइन इंडिकेटर वापरतो. तसं इथलं कुठल्याही टायट्रेशनमध्ये इंडिकेटरची गरज आपल्याला लागत नाही. कलर चेंज आपण इथं बघत नाहीच. इथं फक्त काय करतो आपण, हा जो कंडक्टन्स व्हॅल्यू आहे ही कुठून डिक्रीज होते, कुठून कमी होते, ती नंबर ऑफ आयन्सवर अवलंबून असते, आणि स्पीड ऑफ दॅट ऑन ह्या 2 गोष्टीवर अवलंबून असते. त्यामुळे इथे इंडिकेटरची गरज भासत नाही. एंड पॉईंट ऑफ इंटरसेक्शन ऑफ द 2 लाईन्स, सो नो एक्स्ट्रा केअर. आता मग मी सांगितलं की ग्राफ करतो, ग्राफवरून पॉईंट ऑफ इंटरसेक्शन काढतो, आणि त्याच्यावरून अननोन नॉर्मॅलिटी आपण फाइंड आउट करतो, आणि ग्राफिकल रिप्रेझेंटेशन असल्यामुळे हे काय होतं, सगळं ॲक्युरेट आपल्याला करता येतं. तर अशा पद्धतीनं ही कंडक्टोमेट्रिक टायट्रेशनची सगळी ॲडव्हान्टेजेस आहेत. तर आत्तापर्यंत जो टॉपिक हा झालेला आहे, इलेक्ट्रोलिटिक कंडक्टिव्हिटी, ह्याचा थोडक्यात आढावा आत्तापर्यंत आपण घेतलेला आहे. जवळजवळ हा 75% हा टॉपिक इथं पूर्ण झालेला आहे. उरलेल्या ज्या गोष्टी आहेत आपण पुढच्या तासापासून पाहणार आहोत. सुरक्षित राहा, सॅनिटायझरचा वापर करा, मास्कचा वापर करा, सोशल डिस्टन्सचं पालन करा, आणि व्यवस्थित राहा, सेफ राहा. घरच्यांना सांगा, शेजारच्यांना सांगा. Have a good day. Thank you very much.